Hey everyone, welcome to Code Upwards, where we break down algorithms, data structures, and LeetCode problems in a simple and engaging way. Today we are solving LeetCode 141 linked list cycle, a fundamental problem that introduced the Floyd cycle detection algorithm. By the end you'll know how to efficiently detect cycles in a linked list, an important concept for coding interviews. So let's get started. First, let's give it a read. Given head, the head of a linked list, determine if the linked list has a cycle in it. There's a cycle in a linked list if there's some node in the list that can be reached again by continuously following the next pointer. And then some details. Internally, pos is used to denote the index of the node that tail's next pointer is connected to. Note that pos is not passed as a parameter. Okay, so if there's a cycle, we want to return true, and otherwise we want to return false. So let's look at the example. Here we have a linked list. 3 is pointing to 2, 2 is pointing to 0, 0 is pointing to -4, and -4 is again pointing to 2. So you can see here we have a cycle, because there are two elements pointing to the 2. Now, leveraging a data structure that we have already seen in previous problems, we could simply create a set, iterate through the nodes, start at head, and every time we see a node, we simply save it in a set, and then with every node we can check if we have already seen it before or not. So it started at 3, save the 3 here, go to the next node, now we have visited the 2, save the 2, now go to the 0, now we've visited the 0, save the 4, go to -4, save it into the set, and we go to the following of -4. Now we get into 2. We can check in our set. We have already seen that one. This is definitely a valid approach, and it will have O of when n one time, which is nice, assuming that we have n nodes in our linked list. But we will need to store all the values here. So we'll also need O of n space complexity. And there is a nice trick where you can do this with constant space consumption. So O of 1 space consumption. And this trick is also known as Floyd's cycle detection algorithm. And I'll explain it to you. Let me erase this. So, what we'll do is we'll have 2 pointers, one slow pointer and one fast pointer. And with every iteration, the slow pointer, so the slow pointer will start here, will point to this node, and with every iteration, the slow pointer will move forwards one node, just like we did before. Then we have a second pointer, the fast pointer, that starts at the second node, and with every iteration, the fast pointer will progress 2 nodes. So, why will this allow us to detect any cycles? We will have a cycle if any time in the future the slow and the fast pointer are again pointing to the same node. Because let's say we don't have a cycle, so we don't have this node here. Then the fast pointer would advance, and it would reach the end here, the slow pointer would be here, and we could not move forwards, so our algorithm would be done, and we would say, okay, we don't have a cycle. But that's not the case here. So the fast pointer will go on and run around in this circle, and at some point the slow pointer will also enter this circle and also run around in the circle, but slower. So the fast pointer will catch up to the slower one, and they will meet at some point, and then we know, we have the circle. And like this, we will also only have O of n for the one time, because the slow pointer will only traverse every node once, and then the fast pointer will have catch up to it. And for the space complexity, we only need to save the 2 pointers, so we'll have O of 1 space complexity. let's go to the code.